Okay, so we're going back to page, this is page 99, right? Okay, so on page 99, this was the first time that we graphed sine and cosine on a piece of paper, and we left the transformations box completely blank because we just weren't ready for that right now, right then. So I'm going to give you what that looks like. So your transformations, when they're all put in there, and you don't always have all of them, looks like this. F of x equals a times the sine of b times x minus c plus d, right? So that a, b, c, and d do the same things they've done for every transformation you have ever done. For sine and cosine, a has a name, and c actually has a name for all the trig functions, but either way, they're really doing the same thing. So the a is the amplitude. That's your vertical stretch or compressions. Remember, that's just the absolute value of a. Okay. All right. Thank you. And then the period is going to be 2 pi divided by the absolute value of b. Okay. That's what we've been doing the last couple of days. We just didn't write it in here. All right. Then we have a horizontal shift, which has always been c. It is called a phase shift for trig functions, but it's the same thing. You're moving left or right, so it is c, and your vertical shift, of course, is d. Right. Everybody good with that? Oh, that makes sense. Okay, so move on to cosine, which is, I think, on that same page for you. And we will fill all that in for cosine. That means that this is f of x equals a times the cosine of b times x minus c plus d. Where, again, your amplitude is the absolute value of a. Period is 2 pi divided by the absolute value of b. Horizontal, vertical. Remember, x still lies. And the reason it looks like x lies is because if c is 2 and I have x minus 2, that means I'm moving to the right 2, right? If I have x plus 2, that means I'm moving to the left 2 because that's actually x minus a negative 2. So, all right, we all good on all that? Grab the tangent one then. And we already have some of that one filled in. Fill in the rest. F of x equals a times the tangent of b times x minus c plus d. So then you just need to put in the c and the d for the horizontal and vertical. Okay? That way it's just all in one place for you to look at. All right, so now let's look at actually doing these other shifts, which means we're moving on to this one, and this is on page 103. Is that correct? I already forgot. Okay. 103. Bless you. So we have done the stretches and compressions, but now we're going to look at the translations. So it says, like other functions, trigonometric functions can be translated. Given the functions to the left, meaning these right here, C represents a horizontal shift. We already know that. And D represents a vertical shift. That is old business, right? So vertical shifts. If I have plus D, what happens? Up. Minus D means it's going down. Horizontal shifts or phase shifts, plus C shifts which way? Left, and minus C shifts right. So, old business, right? Even though it's trig, it's the same thing that's happening, so it's not going to be that big of a deal for us to figure it out, even though the trig makes it look a little different. Okay, so then number one, describe the translation. So I have cosine of x plus 2. So what do you think is happening there? Up 2, because if it was left or right, then that would have to be in parentheses. Like I'd have to add the 2 before I took the cosine, right? So that means that this one is up 2. So this one is what? Down 1. Okay, so then here, clearly this is happening before we take the sine, so this is going to be horizontal. What does this one do? Left pi halves. And this one goes right pi. Okay, everybody good on that? We should be pretty good at this stuff by now. All right, so shifting the graph vertically will create a new horizontal axis. This is important because we truly use it as the new x-axis and just kind of ignore the old one when we have it. It is called the midline. Right? So this is a reference line on which the graph oscillates. Oscillates is that bouncing back and forth. Okay? So it's a reference line for us, which we will draw in like we do asymptotes. It's not an asymptote, but it's important for us to have a reference, so we do draw it in like that. So here, if I start with f of x equals sine of x, then I shift it up to sine of x plus 4, then my midline is right here. What is the equation of that line that we just drew in? Y equals 4. So this one, this one specifically is y equals 4. Which means that in general then the equation for the midline is just y equals d, just whatever that vertical shift is. Okay, so it's really easy to figure out. Everybody okay with all that so far? All right, so let's look at number 5. And we're going to graph a bunch of these together because different little things happen that I think is important for us to just practice a bunch together. So it says graph the function, then identify each characteristic. That really doesn't make any sense to me. You really need to identify them so you can graph it, so we'll do it that way. So what is the amplitude for number 5? 3/2, right? What is the period? 2 pi, right? Because nothing changes. Is there a phase shift? No, because there's nothing in parentheses. So this is a none here. Do we have a vertical shift? Yes. Up 3, which means my midline is y equals 3. All right, so the first thing I'm going to do is draw in my midline. So go to y equals 3, draw in that midline. That is my new x-axis. I treat it like the x-axis, and if I do it that way, that takes care of the vertical shift. Like you don't have to worry about counting or anything like that. Is your vertical shift. It's just already shifted up some. All right, so then the next thing I would do is draw in a little graph of my parent function here. This is sine, so it's going to look like this. Okay, so then I think through what's going on here. My parent function, I start at 0, 0. Okay, so this is my new 0, 0, right? The only other thing that's going to affect that is a phase shift, left or right. Do I shift left or right? No. So that is my new 0, 0. That is this point. So since it's on that midline, the end of the period is also on the midline. It's a 0, basically. So my period is 2 pi. So I'm going to go from 0 to 2 pi. The only thing that would affect me putting this point here is if I had a phase shift, and I don't. So that is the end of the period. Once you have the beginning and the end, the rest is a piece of cake. It's half, 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 right? So halfway in between these two is my third 0. So that's here at pi. And then halfway between these two zeros is my maximum. And I know it's a maximum and not a minimum because there's not a reflection. Parent function, I'm at 1, but I have an amplitude of 3/2, so I actually go to 1.5. That means halfway between these two, I go down from the midline 1.5. Right? You just treat it like your x-axis. Then, once you have your 5 anchor points, before you draw in anything else, double check the period. That's one of the most common things I have seen the past few days, is that people are writing down the correct period. Like, you know how to find it, but then that's not what you're graphing. So we said 2 pi. These 5 points just span 2 pi, so we're good. Then we can just repeat the pattern. Okay? Repeat that over here, and then these alternate. And this is my graph. What questions do you have? Anything? And some of this is going to take more reasoning through than others, just depending on what kind of transformations are happening. So make sure you're listening to some of the things that I'm saying. All right, so let's look at number 6. What is the amplitude? Is what I heard? No, I heard the right answer somewhere. All right, so that means that answer is? It's undefined, thank you. It is undefined. However, A is important to us, so I'm going to put it in parentheses. 1 is that A value that I'm still concerned with, but it's not the amplitude. Okay? Then what is the period here? pi, because the tangent for the parent, or the period for tangent parent function is pi. There's nothing being multiplied by x, so it's still just pi. Do I have a phase shift? Yes. I'm going to go which direction? Left. I go left, pi halves. Do I have a vertical shift? No. So this is none, which means my midline is y equals 0. So the x-axis is really my x-axis here. Then I'm going to draw in my parent function so I have something to follow. I cannot stress to you how important that really is for you to keep up with what you're doing. We're going to start with this point. That's normally at 0, 0. Okay? There is no midline, so I am at 0, 0, but I have a phase shift to the left pi halves, so I have to move to the left pi halves. That's my new 0, 0. The end of the period should be at pi, and it should also be a 0, but I have to move to the left pi halves. Or I could have just gone pi from where I started, either way. Okay? So I've got the beginning and the end. The rest is just half, half, half. So halfway in between, I get my asymptote right here. Then halfway between this 0 and the asymptote would be a 1 for the parent function. And since there is no stretch, it really is still just 1. And then halfway between here is negative 1. Then my period should be pi. It is pi. So I feel good to continue the pattern. We good? So then we should be able to continue the rest and get it drawn in then. Okay, so since I can fit a point on either edge, then I do have like that little tail that's still there. If I couldn't even fit a point, then I wouldn't have to worry about putting the little tail there, just as an FYI. I've had that question a few times. Okay, what questions do you have? Are we all good? Okay, so before we move on to the back, your assignment, if you didn't notice, says that you have a worksheet and Delta Math. All right, so I want to show you one of the Delta Math things. You'll actually like this Delta Math. It'll be pretty easy, and it's good practice. You may even want to do it before you graph the other ones. Although I think you can figure this one out, I still want to show you. So, but I have to go back to my desk to type things in because I don't have a wireless keyboard. So somebody that can actually see this closer up, you might have to be my eyes if I ask you some questions. So what this actually says says write the equation of the graph. So it gives you this graph, right? The black one is the parent function. So as you can see, it goes from 0 to 2 pi, if you can see that far away. But the black one does go from 0 to 2 pi, and the amplitude is 1, okay? And I have to make it into this dotted one, right? So I'm going to look at, so the first thing here is the amplitude. So what do you think the new amplitude is? 3. Okay. The amplitude is half the distance between the max and the min. So how far is it between the minimum to the maximum? 6. Well, this is at a negative 5, but this goes up to 1. So it is 3. Okay? So we'll put a 3 there. All right. So then this number that's multiplied is going to be the period. Well, the period was 2 pi. The new period then is, and actually to figure that out, I feel like doing this next actually helps you a little bit with this part. So if we shifted down, how far did we shift down? Okay, so if it goes from 1 to 5, to find this, I can subtract them to get the 6 and then divide by 2. If I add them, 1 plus negative 5, that's negative 4. Divide by 2, I'd be there at negative 2. Okay, does that make sense? All right, so if I move down to negative 2, that means like this is where I start, right? And this is sine. So one cycle is going to go from here to here. Somebody that's closer, what does this number say? 2 pi thirds? Okay. So if that is 2 pi thirds, I got to figure out what number, my period is 2 pi thirds, right? And I have to figure out what number that's going to give me to put in, what would it be? Okay, so the period is 2 pi thirds. What number do I put in here? I don't put 2 pi thirds in here.
Oh, pi over 3 pi. That number is way inside.
Because you take that, that's B. That number is B, right?
That's the period. 4 pi thirds.
Okay, so hang on a second. Hang on. Shh, 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 shh. You do 2 pi divided by whatever that number is, right? Okay, if I need it to be 2 pi thirds, what number needs to go there? Just 3. If that number is 3, if I take 2 pi and divide it by 3, don't I get 2 pi thirds? There you go. Make sense? Okay, you're making it too hard. So, okay, but you do have to think backwards on that one, and that is something that gets confusing. The only numbers that are going to have pi in them in there are going to be the ones that that shift left and right. Okay, everything else is a whole number. No. All right, so let's just say, so do we agree with these? Okay, so I'm going to change this 3 to a 2. Okay, we know it's wrong, but I'm going to change it because I want to show you what happens. Right now, I cannot even submit my answer. Once I have these 3 in here, I'm going to hit try, and it's going to fix it, right? So when I do that, then I can say, oh, dang, it still won't let me submit because I'm not right. But I can see I'm pretty confident that the period is correct. I'm pretty confident that the shift is correct, but clearly my amplitude is wrong, right? So if I change it to what I know is right anyway, 3, and then I hit try again, now they completely overlap, and it actually lets me submit the answer. Okay. You can't get it wrong. It won't let you submit. Okay? But then it shows you a little bit and explains all the stuff. But basically, you have to get it right to submit it. Okay? So you don't really have a choice. But you good with that? Okay. Well, you can just write a little equation. 2 pi over b equals whatever the period is and figure out what b is. Just a little equation. All right, flip it over. Oh, it's a lot easier than what everybody was trying to say out loud. They were just screaming out numbers. I don't know. Okay, truth hurts. Okay, so number 7. And so that's a little, looking at it that way on the computer is kind of backwards from this. Like you're taking the graph and trying to create the equation. Here I'm giving you an equation, you're having to graph it. So, all right, what is the amplitude here? 4. Okay. What is the period? 3 pi. Okay. So, Christopher's question was, is there an easier way to figure it out? So let me just write it down. So on the one that we just had, what was the period? It was 2 pi thirds. So if you write down 2 pi thirds, that is the period. The period is equal to 2 pi divided by b. And if you write it down like that, like that's a piece of cake, right? B has to be 3. And it won't always be quite that obvious, but that's basically what it is. If you just solve for b, then you'll be able to figure it out. Okay. All right. Either way, just like here, let's just do this one. The period is 3 pi. That's equal to 2 pi divided by b, right? Okay, so if I multiply by, like, basically cross multiply, so I can cross multiply and divide, I can get b times 3 pi equals 2 pi. So then I just divide. B is equal to, these two things just trade places. 2 pi divided by 3 pi. And that's why it's 2/3. Okay? That's where that's coming from. And just like when you solve trig stuff, if you just switch places here, you end up with that. Okay? All right. Phase shift. Do I have a phase shift? Right pi. Do I have a vertical shift? Up 1, which means your midline is y equals 1. So the first thing I'm going to do is draw in my midline. That is my new x-axis. Then I'm going to draw my cosine parent function. Okay? So I don't have to worry about the vertical shift because the midline replaces my x-axis. So normally, for my parent function, I start at 0, 1. So from my midline, I would go up 0, 1. However, my amplitude is 4, so I actually have to go up 4 from the midline. 1, 2, 3, 4. So that puts me here at 0, 5. But I can't put a point there yet because I have a phase shift. I also have to move to the right pi. This is my new point that was this one. Okay, so you have to think through those steps. And those of you that stare at your graph and don't know what to do, I don't know how to do it if I'm just staring at my graph either. You need to put your pencil on the paper and actually move it as you have these thoughts. Otherwise, I don't really know how you're supposed to do it. Okay, so we're here. Now this is the beginning. The end would normally be at 3 pi, but then I have to move over pi, so it's way out there at 4 pi, way off my graph, right? So I cannot do that one. Then I would move to halfway, right? Halfway between 0 and 3 pi is 3 pi halves, but then I would also have to move over pi, which again puts me way off the graph, so I can't even do this one either, okay? Before I do the phase shift, this would be at 3 pi halves. Does that part make sense? Before the phase shift, okay. Which means that then, I can't do this one either, obviously it's way off the graph, but this one right here, before the phase shift, what would this x value be? 3 pi fourths, okay? So I can go to 3 pi fourths, which would be a 0, right? Here's 3 pi fourths, but I have to now move over pi, which would put me where? 7 pi fourths, which is right here. And that's this point. So the only two that I can actually get on my graph are those two right there. No, because it's a 0, so it's on the midline. Okay? We good? That's why it's important to have this to follow. So you're like, no, that is on the axis. That is up there. Yeah. Yeah, that's fine. That works too. I don't teach it that way because that really just blows some people's minds. So it's better to stay consistent. All right, so I can only get those 2 points on there. Are those 2 points enough to continue my pattern? The answer is actually yes. Because everything is evenly spaced, I don't need to worry about doing anything weird. If I can get at least 2 points on there, it really is enough. It's way easier if I can get 5, but everything, I know what it looks like. I know that it goes like this, right? So if I'm at 0 here, and then have a maximum, then I'm going to have to come back down to a 0. And this is 1, 2, 3 pi fourths away. So 1, 2, 3 pi fourths away, you're going to have another 0. Then the next thing you're going to have is a minimum. And it's going to have to be 1, 2, 3 pi fourths away. And from the midline, you have to go down 1, 2, 3, 4. Then the next thing you're going to have is a 0, and it's 1, 2, 3 pi fourths away on the midline, and then 1, 2, 3 pi fourths away up here. Okay, does that make sense? So in that case, I didn't do the half, half, half because I couldn't get those pieces on there, but it's still, because everything is half, 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 everything is evenly spaced, and you can find what you need. Okay, are we good? So again, some of these take more reasoning than the others, but you definitely have what you need to figure them out if you're actually practicing them and paying attention. What questions do you have? What valid questions do you have? All right, number 8. What is the amplitude for number 8? Undefined. But what is A? 1. Okay, so I'm going to put 1 in parentheses. What is the period? Yeah, the period is pi halves because I would divide by that too. Do I have a phase shift? Yes. Left pi fourths. Do I have a vertical shift? Down 3. Okay, so y equals negative 3. So the first thing I'm going to do is draw in my midline. Then I will do a parent function for tangents. All right, so tangent starts at 0, 0. My new 0, 0, because of the midline, is down here. But I also have a phase shift of pi fourths, so I'm going to move to the left pi fourths. There is my new 0, 0. Okay. Then I need to go to the end of the period to get the other 0. So the end of the period is at pi halves, right? So I can go to pi halves, but then I have to move to the left pi fourths, and that's the other 0. So you can either go to the end and move to the left, or you can just go pi halves from where you started. Either way, it gets you the same spot. So there's the beginning and the end. Then halfway between is an asymptote. So halfway in between, I will draw in an asymptote. Then halfway between this 0 and the asymptote on my parent function, I would be at 1. There is no stretch and there is no reflection, so I still go halfway between these two and go up 1. And then I go halfway between these two and go down 1. Then I'm going to double check the period before I move on, right? The period is supposed to be pi halves, and that's how much I have spanned with those 5 pieces, so I'm good. All right? We good? And then that's enough to just repeat it and get it all drawn in. Okay. Thank you for sharing. Oh, Lord. Well, you can sue the school district then, I guess. Yeah, you should, yes. Come in. Hi. Oh, yes. I have this. All right, so let's look at number 9. What is the amplitude? 3. And the period? Pi halves, right? Is there a phase shift? Yes, we go to the right, pi halves. Vertical shift, down 2. So y equals -2. So I'm going to draw in my midline. This is sine, so that is basically what my parent function looks like. All right, so sine starts at 0, 0. So I'm going to put my pencil at 0, 0, my new 0, 0 from the midline. The only thing that affects that now is going to be the phase shift. I have to go to the right pi halves, and then that's where my new point is. Okay. The period is pi halves. So I can start at pi halves, and then I have to do a phase shift of pi halves, which actually puts the end at pi. So I have the beginning and the end. Then I need the middle, which is another 0, so halfway in between goes the other 0. Then halfway between these two zeros is a maximum, and I know for sure it's a maximum because there's not a reflection, right? And it's not going to be at 1, it's going to be 3 above the midline, so 1, 2, 3. And then halfway between these two, 1, 2, 3 below the midline. Then I double check that those 5 points only go through a period of pi halves. And they do, so I'm good. Right? We good? And we just fill in the rest. You can fill in all the zeros and then go back and alternate. you go. You don't like playing what? Connect the dots. All right, what questions do we have? We good? All right, let's look at number 10. What is the amplitude? 1. What is the period? Pi. The phase shift is left 3 pi fourths. Vertical shift is up 4. Midline is y equals 4. All right, you graph that one. Aww. Girls, play nice. Okay, so these are my 5 anchor points. I'll take you through my thought process, which may be the same or may be different than yours, but I normally start at 0, 1. So I go to 0, 1, right? But I have a phase shift to the left 3 pi fourths. 1, 2, 3 pi fourths. That's where I got that point, right? That's where this point comes from. Then the period is pi. So I should end at 1 at pi, but again, I have a phase shift to the left, 1, 2, 3 pi fourths. That's where I get that point. Once I get those two, halfway in between those two is a minimum, and then half again gives me those zeros. The midline shifts you up 4. Once you graph this, you're not worried. That takes care of the vertical shift. You don't go farther. Yeah. Okay, we good with that? All right, so let me finish drawing mine in. And if you don't have any questions on this one, you go ahead and do number 11, and once you can show me you have that one done correctly, and then I will give you your assignments. Oh my gosh, I cannot. Just stop it. So I do not listen to anything they are saying.